Hi, ma'am. Good morning. This is Saiteja Joginipelly, and today I am here to submit my project for analysis of algorithm. The goal of the project is that to find the time complexity of different algorithms on the same problem or the same problem, and the goal is to discover how accurate the theoretical estimates of complexity when compared to real-time estimates. Here we are taking two algorithms: brute force algorithm and divide and conquer algorithm, and the input given is like it varies from in 10 to the power of 3 to 10 to the power of 4 with an each increment of 1000. And here is my code, ma'am. I'll show you my code. uh, Here I've imported few libraries, and I've also taken few functions to plot the graph, to compare x-axis, y-axis, and here generate random data, which generate random values, which are taken and which are used to plot in the graph. Like random inputs are given in the graph to process the algorithms, and the distance between 2 points, the two closest points, is taken by under root x2 minus x1 whole square, y2 minus y1 whole square. Here we are not taking the root. Here we are taking the square, and here comes the first algorithm, brute force algorithm. Here the given we are taking the minimum distance as int max, so that whatever the value is it's minimum when it as we are taking the infinity. And here we are taking 2 points, and then we are placing in two for loops. The first for loop, it goes for let us assume they are like a b c d. Then using this for loops, it goes like a to b, b to c, and c to d. Then again it goes from b to c, b to d, and b to c, and again c d. So here the whole in this program, it goes to each and every point and each and every pair. It tries with each and every combination and each and every pair, and gives us the output as the minimum distance, which is continuously get replaced with the minimum distance value. This is brute force algorithm, ma'am. And when it comes to closest pair, here we try to divide the graph as possible. Like first we take the graph, we sort it, and we take a midpoint, divide the graph into two halves, and we find the closest pair on the two halves. And then again we will find the minimum value in the both graphs, like the out of the right side and the left side, we'll take the minimum value. Then using that minimum value as a delta, we will take the distance, like the from the midpoint, the delta distance is used such that no other point is lies beyond the distance, in such a way that we reduce the graph continuously until the closest pair point is received. Here to explain the code, we are dividing the whole data by two. Then again, the points we so get sorted are used over here, which the graph get continuously reduced. And here is the main code. In the main code, we are getting the record of the time. First, we have created a list with times.csv, where we have taken in columns as input size, efficient time, and brute force time, and the time. And then we are taking the start time and stop time, and we are subtracting the stop time from the stop time for each and every iteration, such that we get the duration between the run times. And we are doing it parallelly for the both algorithms. Here it is for the closest pair, and here it is for the brute force. Uh, and the outputs are like placed in the list map. Then the CSV file is taken and is uploaded in the Python code. I will explain in a minute. And the output generated is converted into an CSV file and is placed over this location. Now we'll upload the times.csv file into the collab, into Google Colab, where the Python code is. I'm deleting the previous one now. Upload times.csv. Now I'm running the Python code. And here in Python code, I have taken the values from the CSV file, and I have used using which I founded the theoretical value, where I have taken the input size, and the square of it is like brute force, and np log of 2 is used for divide and conquer. And similarly, I found the values using these formulas, calculate the ratios. I calculated the ratios. I've calculated the constant factors. I have calculated the average constant factors. I have calculated the predicted runtimes and uploaded them into like CSV files. And here, using the points we got, using the data we like extracted, I have created three graphs. In the first graph, I have created in between empirical algorithm one, empirical value of algorithm one, and predicted value of algorithm one, using input as x-axis and or time as a y-axis. In the second graph, I have used an algorithm two, empirical value of algorithm two, and predicted value of algorithm two. In the third graph, I have taken empirical value of algorithm one and empirical value of algorithm two. So when we go to the graphs, in the first graph, the empirical value and the predicted value lie similar, and like they both are in the same plane. But when in the second algorithm, the predict the predicted value is lesser than the empirical value. Empirical value is lesser than the predicted value. And when it comes to the third graph, we can observe that as input increases, the amount of time taken by brute force increases, but the amount of taken with divide conquer is low. When compared to the both graphs, we can say that the time complexity for brute force is high when compared to divide and conquer. This is the explanation, ma'am. Thank you so much.